Exploring hyperparameter space. It sounds complex, but it's actually not. Don't worry, we'll go over all the details here on Machine Learning Basics. Hey everyone, I just wanted to say a quick thank you and welcome to all of my new subscribers, and a huge thank you to all of my patrons over on patreon.com. If you're interested in becoming part of the crew that helps make this show possible, please check out the Patreon link below. And if you're not in a place that you feel that you're ready to or can't provide for this show, that's totally okay, but I just ask that if you find anything in this show informative or useful, go ahead and hit that like button. Thank you so much. So if you rewind the Wayback Machine and go back to when we first got started, we had a simple problem that was happening in one dimension, and we were able to train this, but we knew that we could get it to train faster by training multiple instances of the environment all at once. And so that was actually what we covered in the second week that we've been doing this. Is we created a game creator that would duplicate an instance, right? We had the prefab, we would instantiate the prefab, we would assign the brain, and we could choose how many instances of our game we have training all at once. Now, at that time, we originally chose 20 instances. And part of the reason we chose 20 instances is in the earlier versions of the ML agent's code, there was a timeout that if you had too many instances, the handshake between the environment and the learning script took too long, and the application would crash because there was a timeout. Over time, they have fixed that, and so I've been meaning to go back and revisit how many instances should you really be having when you're doing your training? How high can we take this? And I got some very interesting results, because the results that I got were semi-conclusive at first, and then they showed me that there was something more going on than I had really anticipated, and that is this. When you are doing your training, there's a certain number of steps before the application performs a gradient descent. That is to say, before it learns something. And so the more environments you have, the more information it gains before it learns something. If you don't have enough experience in there, then it learns when it is unexperienced. If you have too much knowledge in there, it actually seems to be very conservative and only learn very safe things, and it doesn't learn rapidly at all. It actually seems to be detrimental to the overall speed in which that it starts to learn something if it gains too much knowledge without having actually learned anything from it yet. So it turned out that as I was playing with this number, that there was kind of a sweet spot for this application. And so if you are doing training with multiple instances, there may very well be a sweet spot for your application as well. So in this video, we're going to go over how I parameterize things so that I could automate exploring that space a little bit. And again, what it kind of looks like in TensorBoard. So I'm going to go ahead and open up our 3 inputs. And so again, we're just looking at this problem, and this brain that's going on right now, this is the one that's been trained on 10 million iterations. And that's a very long time. That's like 16 to 20 hours worth of just cranking away, which is a very, very long time to learn something. And the performance we got was only okay. And so this is one of the things where I wanted to go back in and say, can I get more experience and train it on more faster, and what does that look like? And so I cranked it all the way up. I just went and I pegged it at 100. And you know, when I pegged it at 100, it turned out that the performance after was actually very poor. And so I was, you know, scratching my head a little bit, and then I said, all right, I'm really going to go in and I'm going to do this in a at least semi-scientific way and really explore this space and see what I come up with. So the first thing that I did is I went back to my code, and I went back to the curriculum learning code, and I added a parameter in the game creator. And so what this does is this environment duplicator again, we have this layers value you can see right here, and we're saying just create 20. And again, that was the default that I used because it was a fair number, and then that wouldn't crash the system in ML Agents 0.2. So I went in there and I put in a super duper cheesy approach to parameterizing things. I don't really advocate this from a software engineering perspective. However, it was a very educational hack. And it does have one benefit, which is that it's easy to modify this file from a batch file. So we have a file name, layers.txt. If that file exists, then we read from it, we make that an integer, and we say that's the number of actual layers that you use. So now if you look at my directory structure, I have one executable for this 3 inputs. I'm no longer required to have one version that has 10 and one version that has 20 and 40 and 100. All right, this is kind of an early version. Now I have this X layers that just looks at this layers.txt file, which just has a simple number in it, right? 20, 100, whatever. And then that way I could just, batch a whole bunch of different options up and run it overnight, and I can see what happens in the morning instead of me babysitting and trying to do these runs individually. The other thing that I can do with that then is in a batch file, you can actually have a loop in Windows. I know in Linux you can do all kinds of things with your shell scripts. But in Windows you can have loops in your batch files. And so what I did was, I know sometimes you just get unlucky or you get really lucky, and I wanted to get better information, right? I wanted to have a higher sample of data points so that I could get a real feel for, is this value doing well or is it doing poorly, and that it's not just random luck once, and see if we can pull out any trends. And it turned out that we're absolutely able to see trends in it. So you saw the code, it just goes to the file. If it's there, it reads it in, and then it uses it. Ideally, yes, I would like to have some kind of JSON parameters file, but what's interesting about this is now we're monkeying with the amount of data that it's using for the parameters as it's learning, and so we're actually changing some of the hyperparameters of the overall system, and by doing that we're changing its behavior. And so I also want to think about, is there a way that we can maybe create a better high-level way of modifying hyperparameters over time, and I'll show you one of the big advantages of that in the next video that I'm going to do. So for now, I'm just going to focus on this. I'm going to show you the data and kind of what we're seeing and why I think it's important. So let's get to some charts. All right, TensorBoard is up, and I'm going to open up the cumulative reward. Oh, before I do that, sometimes TensorBoard has been chewing up a lot of my resources, so I'm going to, in my curriculum, I have the comparison. So I ran this experiment with 1 environment, 5, 10, 20, 50, and 100 environments, right? And so I was able to compare how much learning, and I said, I think it's 100,000 steps. You get 100,000 steps, or maybe it's 50,000 steps, and that's all you get. So whether it's 1 environment or 100 environments, we're just going to run for a set number of sets, and I want to know, does it change the amount of time it takes to actually run, execute, and gather all that data, and does it change the performance? And we have absolute results on that for this environment. For your environment, it may or may not be different, but I'll show you the scripts that I use to do it so that you can set it up for yourself and run some quick experiments. You just run them overnight real quick just to see, hey, does this help? Does this hurt? Because in some cases, it does actually hurt. All right, so we're going to run the comparison. So I'm just going to show you the output here. So this guy up front, this is 1, and you'll see that he crashes a lot, flies off into the ether a lot, right? This one is 5, then 10, 20, 50, and 100. And you'll notice that this 100 one is not doing great. And you think that should be doing a way better because it has 100 times the experience of the one that only has 1, right? But you'll notice that the ones in the middle are much more reliably landing. And again, it's hard to tell which one's going to be the best. You need to go through and get some empirical data. Well, that's what TensorBoard is for, because that helps isolate the lucky from the statistically significant. All right, so so I ran each experiment 5 times, right? And so again, one of the nice things about doing this in a batch file is everything's very consistent. So you can see over and over again that all the naming conventions are exact because I'm not doing it as a human. The computer's taking care of it, and that's what computers are for. So we're seeing similar behaviors, right? It starts off at the same point, and it goes to 100,000. And one of the things that I think is very interesting, and thank you TensorBoard for making this easy, is by clicking on relative, this gives us an idea of how much time did it take to execute this. So it took about 5 minutes to do 100,000 iterations, right? That's nothing, right? And so this entire set of 5 experiments was done in under half an hour, and its overall reward is in the 1 to 2-ish range, right? This all clustered together. So that is a very clear result, in my opinion, right? We're not scattered all over the place. Certainly here in the middle, we are scattered all over the place, but by 100,000, we had generally tightened up into a small group. So I'm going to choose the pink one as our representative of that set, right, of that configuration. So then I'm going to do the same thing with the 5x. So in this case, we have 5 environments running at once and all collecting data. And again, it will collect for the same number of steps, then run a gradient descent. What's interesting about this is it does not take 5 times as long to run with 5 times the amount of environments, right? So there's definitely a speed up in the amount of experience that we're gaining. So that's very good. It does take more time, but it is, much, much smaller than 5 times the amount of time. So that's actually really good. So we're improving the overall system performance so long as, or I should say, we're improving the overall throughput, but that's only valuable so long as we are improving the performance. However, we can see that all of these scores are better than our representative for the first run where we only had 1 environment. So all of the 5 environments seem to do better than a representative from the 1 environment. So that is a very good improvement. And again, I want a representative member, so I'm going to go for the red one because that looks like that's kind of the average. So we can see, yeah, it took a little longer, but really it did significantly better than just running through with only 1 active environment at a time. And we kind of saw that when we were running it in Unity. All right. Now we get down to 10, and we're going to have to rescale this, right? Because we took longer, but this step from 1 to 5 looks like it's about the same as from 5 to 10. So that's interesting. It looks like it may be scaling linearly, not exponentially or anything like that, and actually, or scaling with a constant. So it's the scaling here, again, this did not take twice as long as that. It looks like the number of environments does have an impact in terms of how long it takes, but it looks like you'd actually be able to figure out how much of an impact that has based on how many environments you have, which is interesting. And again, we look at it and we say, all right, well, there's some general improvement. Again, this is clustered pretty tightly together. There is some general improvement over the representative average here. I would say probably, some of the better 5s did not as well as the lesser 10s. And again, some of this is just luck, right? As that entropy value fluctuates, it's going to explore and experiment in different ways. But it generally did better with 10 than it did with 5. So that's, again, useful knowledge. So certainly it is better to execute a training run. And again, we did 100,000, right? And this took us, 8 minutes per run instead of 5 minutes per run. So that's only, 3 minutes longer for 100,000 steps. So, if somebody said, well, which configuration are you going to do a really long overnight run on? Absolutely, I'd pick 10 every time. That was until I ran 20. Now, 20 is where things I thought got a little interesting. That's because there is a major divergence here. So this blue line did about as well as the 10s did, or about as well as the 5s did. And then this one did about as well as the single environment. But these three up here as a group did very, very well. And they're far superior to any other runs that we've seen. But also we're seeing this very large spread. And some of the things that we're seeing here is evidence that some of the things that happened very early in a training may have a cascading effect where some executions, even though you're running with the same parameters, some executions are just going to find stuff, they're going to get lucky, and they're going to learn the right things earlier, and that's going to carry through and affect their overall performance over time. So like this red line right here, overall, its average is actually very, very good. It ended a little further down than the gray, but the red and this gray are very good, and this orange caught up and got very, very good. So these runs are very encouraging. So again, I'm going to choose the red one as roughly representative because these two, well, I mean, with only 5 data points, you can't really see that they're outliers, but they're certainly not the best of what we have. So we're going to go ahead and, again, we'll choose the red one here as our representative of that group. And just keep in mind in the back of our heads that that had much greater variance than some of the other ones did. All right, so let's pull out the 50s and see. Okay, here's another one. The variance, the amount of spread now is getting very, very large. This gray one did fantastic. Now, again, it's further out here. It still did the same number of steps. It just took longer because there's more simultaneous environments, so it takes longer to collect all that data and process that data. And so we're here, and this is now 21 minutes per 100,000 steps as opposed to 5 minutes per 100,000 steps. So you are definitely seeing a performance drop overall. It does take longer to do, although, again, it's definitely not scaled. You know, it's not a purely linear scale. Like, there's definitely something helping us because, you know, normally this is 50 times the amount of data, but it's only taking us 10 times as long. So if it works, this is really, really great, especially gives us, you know, 50 times better. Well, some things definitely did get better. This gray line did, well, pretty bloody fantastic. The orange, pink, the orange one's okay. The pink one's meh. You know, it did about as well as our folks here in the 10 and close to the 5s. And then these two did fairly miserably. Again, it did better earlier, but it again took this very kind of conservative thing. And so it looks like we're still spreading, but actually things are coming down a little bit, which I thought was really interesting. So what do you choose as your representative of this? And the answer to that is I don't know, because we're super spread out. You know, this one seems like a really good outlier. These two are really bad. So we'll just go ahead. Let's go ahead and just leave the gray and the orange as possible representatives. That's fine. We're getting down to the end here. So now we have our 100. And again, we'll scale this. Now, I also find it interesting. One of these runs took way longer than the others, and I have no idea why. I think it was the very last one that I did. Nope, it's not. It is the first of the 100 runs, and for some reason, it took 37 minutes instead of 35 minutes. Again, it took 6 times longer to run, or 7 times longer to run 100 than it did to run 1. So, again, if we're learning something, if we're getting something valuable out of it, that's really good. But what I'm seeing is, overall, the performance of this is actually worse than any of the 50s, and it's worse than the 20s, right? So the performance at 100, what's happening is it's learning so much experience before it does a gradient descent, and so it's learning that all of things are bad because it's not capitalizing on any of the things that are good. Now, you could go back, take this knowledge, and see if you can adjust how frequently the gradient descent happens. That is one of the hyperparameters, right? And so going back in there may help you regain some of the performance, right? And then while still maintaining this really good throughput. So again, I'm going to show you, I'm going to bring it back to step and show you again our cumulative rewards. So at the 100,000 step mark, right? Oh, let me put it back to relative just so that I can pick. All right, so we'll pick this pink one just because it's better than the average, but it's not the absolute best. And we'll just say, yeah, it's roughly representative. Okay, and then we'll move this back to step. And so you can see here, and we'll do the comparison as we look, that the highest value, the highest single value we got was one of the 50s, right? But then 20, and then another 50. We kept that one in there. And then the 100, and then the 10, and then the 1. So, sorry, then the 10, then the 5, then the 1. So the number of environments absolutely has an impact on how well your training is going to perform. And when you look at all of these next to each other, it becomes very clear what your overall trends are. And that will help you select the right number of environments so that you can do a longer training run. Now this does, take a while to do because we did like 30 different runs. So even at 5 minutes a run, anywhere between 5 minutes a run and 30 minutes a run. So it does, take a while to do, but if running this overnight, one night, helps you really select better parameters so that all of your future training is better, that's certainly, in my book, a worthwhile investment. So you can see, these little ones up here, and then here are the 20s, and then here are the 50s, and these aren't that far apart, but it's certainly the 20s execute faster than the 50s. And then the 100s, again, not performing well, taking a lot longer, and, just not getting great scores. So to do this, I am going to show you the run_group.batch file. Now, I could have done this in 2 loops. I just did it in a series of 1 loops, but yes, I could have done this in a pair of nested loops. But basically, what I'm doing is I'm writing out the number 1 to that layers.txt file, so it overwrites whatever's in that layers.txt file and just says, puts a 1 there so that the next time we execute the program's going to go find that layers file, read it, and say, okay, I only want 1 layer. I only want 1 instance of this training environment. And then it does a start wait. So we don't want these to run in parallel. Batch files like running in parallel. This makes sure they run serially. So it'll start it up, it'll wait, it'll run the learn, use the X layers, give it a run ID, and then it uses the loop to name it so they're very consistent, and then training, and then the save frequency. So this is actually identical except for this number here, where that just tells me how many, right? So the number of layers there and the number of layers there, right? How many instances of the training environment, each instance going into 1 layer. How many instances of the training environment are there? So I'll make sure that I get that up on the comments below the video so that you have that, so that you can start exploring this kind of space. Ideally, I would also like to go and start doing something similar for the training config YAML file, but it does require, having a program that would go in here and make some changes. Totally not that hard to do. I was just hoping that there was some way that I could unify the trainer config.yaml and then plus my own environment config so that I can configure it all under one umbrella. I haven't seen any way to do that really right now. So I think there's 2 separate configs, and it might be that, we just have to define a master config that outputs to 2 different configs or something. But for now, just having that layer impacts enough stuff, but certainly it would be possible to have a little program that you, again, run from command line or something that goes in, makes an adjustment to the trainer config between runs so that you can explore other hyperparameter spaces to see if there are clear improvements or clear degradations based on some of the parameters that you pick. Because, like now that we know 20 instances is for this problem a very, very good number, or 50 is also looks like it is a very good number. Maybe you want to change the learning rate or the memory size, or who knows, right? You could change all kinds of things here in the hyperparameters programmatically to explore and see if you can kind of self-optimize your training configuration so that you're spending your time looking at the right problem. So next video, I'm actually going to talk about that a little more. Something interesting that I did got me some very good results. But in the meantime, I'm going to make sure all of this gets up, and I'm going to encourage folks to explore their hyperparameter spaces because this was very eye-opening to see that I had gotten very lucky in many ways just by selecting 20. That happened to be a good, healthy number, and that I could have been having an absolutely terrible time trying to train this if I had just inadvertently chosen a different number of layers and it turned out that it was a poor number of layers for this problem in this configuration. So any comments or questions, please put them in the comments below. I will do my steady best to answer as many of them as I can. In the meantime, go out there, explore a little bit, have some fun, and I hope you have fun doing your machine learning.